Hi everyone, my name is DeLeon and my project is feral hog identification through transfer learning on an object detection model. Here in Texas, no joke, feral pigs are out of control. They are widely considered to be the most destructive invasive species in the United States. Feral pigs cause tremendous damage to crops, livestock, waterways, native plants, wildlife, and local ecosystems. Their annual damage is estimated to be around 1.5 billion annually, and 2.6 million hogs reside in Texas alone, which counts for almost half of the total US population. And that population only continues to explode. So I'm excited to tackle this project because not only am I super interested in computer vision, I've witnessed these pigs' incredible destruction firsthand. We'll cover object detection, the model I chose, how I trained the model, data set, results, and the next steps. So computer vision is a field of study that develops techniques for computers to gain a high-level understanding from images or video input. These are a few of the core computer vision tasks. For this project, I'll be working with object detection, which predicts classes, bounding box locations, and it does this for multiple objects in that frame, as well as multiple instances of the same object in that frame. I chose a single stage detector called You Only Look Once. The model's architecture consists of three main parts: the backbone, the neck, and the head. The backbone is a 53-layer convolutional neural network. And what's happening here is in that network, filters scan the image to pick up identifying features like horizontal and vertical lines, curves, edges, and even texture. The result of all these filters is a feature map, and these feature maps are fed through the neck, or processed by the neck, fed to the head, where the classes and bounding box predictions are made. For the data set, I collected around 4,000 images in 6 animal classes from Google's open image data set. The skunk class, as you can see on the far right, was imbalanced just due to the lack of annotated images in the Google's data set. And we'll see the consequences of that in the results slide. Cat and dog were the only classes that were previously trained on the original model. The other 4 are unseen. So to do this, I used transfer learning, specifically fine tuning. And what that is, transfer learning is a machine learning technique where a model developed for one task is used as a starting point for developing a model on a second task. So for this project, we'll use the convolutional neural network, what we call the backbone, as is from the original model, and we'll transfer that over and we'll just retrain a new head for the second model, specific to our 6 classes. And so utilizing this pre-trained convolutional neural network reduces the training time from days to hours, and it also reduces the size of the data set that we need to get reasonable results. And one of the reasons I chose this model is that unlike some other object detection models, this particular one can be trained on a single GPU. Here are the results. The model achieved a mean average precision of 92%. It's not bad. The mean average precision is the main performance metric used to evaluate object detection models. It in part includes measuring how well the predicted bounding box overlaps with the actual bounding box that was annotated. And as you can see in the notes below, the skunk class had the lowest average precision of 80.7%. Not surprising considering that the data set was lacking in that class. And on the top right, we have an image of some dogs and 1 pig, and it looks good to me. But the main reason I chose this particular model was that it's very, very, very fast in processing images, and it's great for real-time object detection. So as you can see here, you'll see the colors, the frames change and, update the prediction, but it's a little unstable, but it appears to accurately identify pigs most of the time. So for the next steps, I'm going to continue improving and in training this model. I'd like to build a larger data set with particular attention to finding nighttime images of pigs, as in the use case that I'm envisioning it for. It's going to be mostly nighttime use, and as well as build up some more images for the minority classes like the skunk, and then add other animals as well. And what I'm really excited about is getting the chance to have the time to code this up from scratch. This is the tech stack that I used. And if you have any questions, please let me know. Thank you.